Hello and welcome to the Smooth Scaling podcast, where we speak with industry experts to uncover how to design, build, and run scalable and resilient systems. I'm your host, José Quaresma, and today we had a really awesome conversation with Ryan Sherlock, who's a director of engineering at Intercom, and they are a leading AI agent and help desk solution for customer service. Ryan walked us through their evolving journey of database scaling at Intercom in the last 10 years, as well as their unique strategy around incident response and leveraging heartbeat metrics to detect and react to incidents early. I really enjoyed it and learned a lot from it. I hope you do too. Welcome, Ryan. It's great to have you on.
Thanks. It's great to be here.
And I would like to start kind of straight into kind of hearing from you and your experience. So you joined Intercom 9 years ago, right? And can you walk us through a little bit the original setup or the setup that was in place at the time, and any kind of initial scaling pains that you started feeling at the time?
Yeah, I think when I joined Intercom, I think a large theme was actually scaling pains. So we'd been running a couple of years, but we had hit this rocket-shaped growth. And in Intercom, we really value product engineering and solving for our customers. And at these times, potentially not thought long enough about some of the infrastructure that we need to be able to actually support that scaling. And so the first couple of years when I joined, it actually was a lot of firefighting. Like, I remember my first day, I joined, and the area of the app responsible for our user model. So in Intercom, we allow our customers to be able to send targeted messages to their customers based on basically any criteria. And we had a large system to be able to deal with this. And it was basically going down every day. So it was we had a system that was built on, at that point, it was MongoDB and Elasticsearch. And my first day was sit down and then just watching fires going on around me. Now, fortunately, over the next year or two, we were able to get on top of all of that. And since then, it's been much more proactive scaling. But the very beginning was, it was a fiery start to my Intercom career.
Usually, it's a lot of the scaling pains to go towards the database and kind of the transaction limits that you start facing it. Can you tell us a little bit about kind of what were the considerations and the work at that time?
Yeah, no, so I can even roll back a little bit earlier. Yeah. So as I was saying, we tried to build simple and then layer on complexity when necessary. So Intercom started as, the database layer started as a simple RDS MySQL database. We called it MainDB. We still have a MainDB. MainDB has now over 1,000 tables. Yeah. So that one, when we started in 2011, it worked fine. Then 2013, we started having incidents. The first thing that we do is, it's in the textbook, it's you vertically scale. So instead of whatever size instance we had from AWS, we quadrupled it. And then that put us more runway. And fortunately, the business is going well. And then we went to the next bit of the textbook, and it's horizontal scaling. So later we will do per customer sharding and things like that. But at this point, it was just something simple. We'd have a particular piece of the product, and we'd be okay, we think there'll be a bunch of tables in this piece of the product. Let's just add another database for that and put all those tables in there. So in that way, we were kind of splitting up the load. And more runway. But as the business continued to grow, we needed to find more ways of handling the scale. And one thing that luckily we landed on quite early that massively reduced the amount of queries that we were sending off to the database was identity cache. So we're a large Ruby on Rails monolith, and as is Shopify. And Shopify had a gem called identity cache, which was basically a way of caching read queries to the database. So we had gone from near daily outages to back to normal. Our databases were super healthy. And another thing at this time, like, so we were on pretty basic MySQL at this point, but we were pretty, and we still are, we were close with AWS. And in 2014, they announced a new database product that looked magical, which would become Aurora. So in early 2016, we switched across to Aurora. And then again, that gave us another period of scalability.
Yeah.
So it's as time went by, like from the very sort of simple setup at the start, we layered on more complexity. And as the app grew, we had to layer on more. So like at a certain point, our scale got to a stage where we were running over 16,000 Rails processes. And each Rails process would want a connection to the database. And Aurora's support was 16K connections at max.
Okay.
So so then that meant we ended up rolling out ProxySQL, which was a way of scaling that. So like if we had a web serving instance that would have, say, 1,000 processes running on it, we'd run one layer of ProxySQL locally on that host. So maybe we would take 1,000 down to 24, and then we'd have a remote layer of ProxySQL as well, which would then further scale that down so that we were able to like stay well within Aurora's 16K writer limits. But doing that added complexity, and some of our gnarliest incidents until about 2 years ago was related to these various proxy layers and a database and things getting into meta-stable states, and at times us basically having to reboot Intercom, which would be going to all of the instances, restarting the instances, and then getting recovery. Yeah. So like, this takes us up to like 2019-ish. And at that point, I think it was a year or two earlier, at reInvent, AWS had mentioned that Intercom had one of the largest tables in all of AWS Aurora. This is really bad. Like, you should never be the largest anything. When you have a vendor like AWS and the scale that they operate at, and then you find out you're the biggest of something, like, that sounds like a problem. And it was like the particular table in question was our conversations table. So for every conversation between a user and a teammate would have an entry in there, and we had tens of billions of rows there. And like we had a lot of complexity in the indexes. So if like, let's say there was 1 gigabyte of data, there was like 3 gigabytes of indexes. And that all meant we basically couldn't migrate the table at all. Like it had been years since we were able to migrate it. So then that put us finally down the journey of actually doing application sharding. And the way we did this was for each customer, we would create a schema in a set of clusters. So basically each customer would have a database for their high-scale data. Okay. So what that sort of bought us was, instead of having one massive table that we weren't able to migrate, we'd have hundreds of thousands of much smaller tables that we could migrate, but would just take a long time. So it was relatively quick to roll out, and then that bought us like another 5 years of runway up until a project I started 2 years ago.
And when was that? Because I know that now you do run in different regions. When was it that you also have you always been running in different regions in AWS, or is that something that has happened somewhat concurrently with some of the things you're sharing?
Yeah. So it was about 5 years ago. We introduced an EU region. So with our regions, like, and if you're a customer of ours, like your workspace and your data will reside in a single region. So we don't run data across multiple regions. And the driver behind having an EU region was we had many customers that wanted their data and everything related to it, fully based in the EU. So that was a driver to drive that out. And like the way our infrastructure works across the various regions is it's largely a copy. There's largely a carbon copy of like our US East 1 region is like by far the largest region. And then the EU region, it's basically the same. There are some things that we optimize from a costs point of view, where there'd be some background queues where in the US region, we would have like one cluster of workers for one queue, while in the EU, we may have some shared queues for less priority work or for lower priority work. But for anything that's high priority, like anything related, directly related to a customer talking to their end user, like that would all be its own infrastructure.
Sorry, I kind of interrupt you there with the regional question, but you were sharing kind of from the database evolution, and you were at the kind of the customer sharding kind of step, right? And what happened then?
Yeah, so like it was coming up to like it was about this time 2 years ago, and like Aurora had been like a magical piece of software that gave us like years of scaling, but there were several things that were impacting us that we wanted to change. So like one of them, and I referred to it earlier, was the connection proxying.
Yep.
So that layer was like it was the root cause of most of Intercom's major incidents up until 2 years ago. So there was like for many of our customers, anytime Intercom is down, like their business is down.
Yeah.
So we take this really, really seriously, and we like it was untenable to stay in a situation like that. Next thing was database maintenance. So with Aurora, whenever you wanted to do upgrade the database, it was basically downtime. So it was a maintenance window. And our customers are global. So like we do have highs and lows. Like the low is less than, say, 3 p.m. Irish time on a Monday. Like the traffic is high then, but like we have customers all over the world.
Yep.
And for like any point in the day is for some set of customers the most important time of their day. And like also I did every database maintenance window. So like I was always the along with one of the engineers, and like they kind of suck. They suck for us, they suck for Intercom generally, they suck for our customers. We basically wanted to architect our way out of that. And then the final bit was the native sharding. So we had this, like we built out this per customer sharding, but like it sounds, a per customer schema, per customer database. Like it sounds really cool, but it actually did introduce a lot of complexity. So anytime we want to do a database migration, like let's say we just want to create a new table, that instead of like one migration, it'd be 400,000 migrations that we would be running. And like, it's doable, it's fine, but there was a lot of complexity pulled in that we could start to see that was impacting engineering velocity. And then we wanted to move away from it. Now, when we looked at doing our own application sharding, we did look at Vitess. Yep. So Vitess was the software YouTube built and then later open sourced to scale MySQL. Like Slack use it, HubSpot use it. There's many like large organizations use it to scale MySQL. At that point in time, and I think this decision is still right, we felt that it was too early for a company like us to take on and build a team around it. Like we weren't you'd typically run it on Kubernetes. We weren't running Kubernetes in production. We thought that the learning it would be too difficult for us to get up and running without potential issues for our customers. But in 2023, it actually changed. There was a company called PlanetScale, and they do a managed version of Vitess. And it seemed to tick all of our boxes. And so we kicked off, started doing some prototyping. It looked good. And then we kicked off a migration about this time 2 years ago. The migration, like all things, took longer than we expected. But there was significant complexity in us unraveling from our per customer databases back into something more standard. Like there was some nifty novel engineering work, and in Intercom we tried to not do novel engineering work from an infrastructure point of view, but unfortunately in this case we had to.
So so you're saying that in this setup you went away from per customer schema. Can you tell a bit more about that?
Yeah, so like for our high scale data, each customer would have their own database previously. So like their comments table or the conversations table, message thread, a lot of data around the customer itself. In PlanetScale, what we have is to the app, it's logically one very large table. The Vitess layer, what it does the magic of from a Rails monolith, converting that into the correct query to access the right shard within a very large cluster. So for example, previously we had 5 Aurora clusters, and across those 5 Aurora clusters, we had 400,000 like workspaces. Now we have to the application one table, except it's spread across 128 clusters. And those clusters, like we're back at a place where we have many different levers we can pull for scale. So we can scale up the instances, we can add more readers, and by a few clicks of a button and some wall clock time, we can reshard. We can decide, hey, 128 isn't enough. We've grown enough. We want to go to 256 shards, and those are just a few clicks away without a lot of engineering from say the teams in my group.
Yeah, and no longer the need for the proxy layer either.
Yeah, the proxy layer is gone. It's their equivalent is something called VTGates, and it's like it's a very nifty piece of software where in Vitess we can now do basically maintenance-free upgrades. So in Aurora we'd have upgraded like maybe once per year because it was an hour of downtime for our customer. And now, since we've rolled across, I honestly can't tell you how many times we've upgraded. It's probably 20 or 30 times. It's maybe more. And what it can do, like this layer, it can, when you're doing an upgrade, you can just upgrade one of the replicas, upgrade the other replica. And then on the VTGate layer, when everything is set up, it will pause writes for a split second. It will queue them up. It'll point off to one of the upgraded replicas. And then it will release the writes again, and then that other replica that was a writer will get upgraded. And it's pretty magical. It sidestepped two of the major problems that we had.
I can see how that really simplified a lot of the work that you were doing, and I guess increased the engineering speed again, right? With removing all those dependencies, or at least kind of you get that for free from that system, right?
Yeah, and one of the problems that we hit, and it's complexity in code, where when we per product sharded, what that meant is we had several databases that would be responsible, or that would need to be kept in sync in a single request. For example, in the past, if we were creating a new comment, we would need to update the conversation. We'd need to upgrade another model called message threads, which would be in a different database, and then update another model, or like create another model called comment, which is in another database. And now you're opening multiple transactions across multiple databases. So like we're rolling back away from that. One of the things that like getting back to this with the way we can scale on Vitess is we expect to put all of our potentially shardable data back into this very large production database. And then over time, once we have the conversation and the message thread and the comment all within the same database, we can remove complexity from the code, which also slow down it increased latency of our requests as well.
How much of a runway do you think you have now, right? So if you're looking forward, is it do you have an idea of is there a clear limit that you can think of from a transaction perspective, or do you say, okay, yes, we think that in 2 or 3 years we'll have to do something again if we continue with our growth? Is that something? How do you think about that?
Yeah, I was in all hands a couple of months ago, and our CEO Owen, he was putting up some graphs on the growth of various aspects of the business, and I was sitting there being like, "Oh my,
yeah,
I am really thankful that we kicked off this piece of work," because like. Which is a way of answering the question. Like, I think it's largely limitless. Like, there's always going to be things that we hit. There'll always be these small things, but I don't think there's anything, at least within like our databases, that we have to do to solve scaling. Because there are companies that are running 100x our data on this exact setup, and as long as we have a large enough credit card to pay AWS for the instances, we can scale largely infinitely.
That's a good place to be from that perspective, right?
Yeah, much less stressful.
Yeah. I guess it has been already kind of a quite the journey in from this specific perspective. Is there anything that you would kind of any advice? So if you have a startup right now, kind of being still kind of small and but expecting to scale, I mean, do you have any advice for them in terms of kind of knowing what you know now with what you had to do?
Yeah, I think like we now run like over 2 million queries per second. So a lot of these, particularly towards the end, the things I talk about, like they're only really problems when you've really scaled and they become problems. And like you probably shouldn't do a lot of this sort of architecting until it actually is a problem, because you probably should be trying to find customer like product market fit. Now, the only exception I think to this is if you're starting a startup and you have data that is in any way shardable. So, for instance, it could be a customer. Then having every table that is related to that customer, having customer ID or whatever your equivalent is on that table, and then having every index start with that customer ID. And like you're adding a very, very small amount of complexity, but it basically means that like if you do hit like massive growth, then going and sharding and doing some of the stuff that I talked about earlier, like it's all much, much simpler. So like some of the parts that was complex for us moving across to PlanetScale was we had lots of tables that like didn't have indexes in the appropriate locations. So then even before we could move stuff across, we'd have to go and we'd have to run big migrations, and these tables are very large and there's like weeks of wall clock time waiting for all of this. So I think there's one small thing that can sidestep a lot of problems, but doesn't actually slow you down from actually building a product that will hopefully scale.
Yeah, awesome. Thank you for that. And I would like us to maybe change a little bit the topic and direction here, and because one of the things that I've also heard you talk about and read was around that in Intercom, kind of from your incident response strategy, you have a strong focus on heartbeat metrics. Can you tell us a bit about what are those and how Intercom uses them?
Yeah, so basically it's a way for us to monitor customer outcomes and not actually, we also monitor the systems as well. But like our customers hire Intercom for a couple of jobs, and largely boils down to customers being able to talk to their users.
Yep.
And in all of our regions, we're at a scale where like we have like real good data, and you can see the seasonality across a day, across a week. We know what we're expected to see from a number of comments being created, number of thin answers being created. We have a really good idea of what that should look like. So if we ever see a deviation from expectations, then we say like the heartbeat metric is fired, and that instantly kicks off our incident response. Yeah. So for instance, if even the heartbeat metric dropped off by 50%, an incident would be created, an incident commander would be paged in, the relevant person on the team would be paged in, or if it was out of hours, the out of hours on call would be paged in, and we'd have automation that would roll back production by 20 minutes. If there's been any deployments in the last 20 minutes, we'd automatically roll back.
Okay.
And then Yeah, and we have additional tooling layered on. We use Incident IO, and they have AI SRE. So at the same time, it'll be working in the background, trying to pull out any information. Does it look like any of the other incidents that we've had? Are there any issues that are just opened around this? Again, so that like the initial responders have a bit of context when they come along. And there's a few examples where we saw this. It was a few months ago. There was an incident where some code rolled out. Within 30 seconds, the heartbeat metric fired.
Wow.
It initiated a rollback, and our rollbacks are like about 2 to 3 minutes we can roll back our code. And we want it faster, and we're actively working on making it faster. And that whole incident was about 2 minutes. So like our customers would have seen 2 minutes of impact. I remember those sort of shape of incidents, say 3, 4, 5 years ago, and it was like the 10 or 11 minute incident. The heartbeat metric. Oh yeah, for the initial response. And so I'd been an incident commander for years, and like the first thing that you do when I see the page come in and you're about to join the incident call, like you want to understand like what is the customer impact. Because like that really sets up the next set of things. Because if you know that the customer impact is really bad, then you'll really instantly want to go to our status page product, update the status page, make sure our customers know that we're on it. The heartbeat metric, like, you know, is the first dashboard that it ever opened. And like that really scratched that itch for me as an incident commander. And then like once we had that, we saw the signal was so strong that we rolled it out into more and more things, and we increased the sensitivity as well. Initially, we would only create an incident if it was like 3 minutes it was down, but it got so good we do it in 30 seconds.
Nice. Yeah,
we could probably do it even less than that at this point.
And is that kind of what are some of the kind of the metrics there? I think is it all around? I guess you talk about customer outcomes. So is it also in terms of thin responses to tickets or conversations? Is it comments from the human agents? Is that kind of all that those sorts of metrics?
Yeah. So we have various database tables that we would be able to monitor, or various rights tables.
Okay. Yeah, at that level.
So we'd have tables associated with Finn is answering questions, or various metrics around Finn is answering questions. So if we see any deviation there. Or then, like I mentioned, the comments table earlier, like the comments table does a lot of heavy lifting here. So if we see comments coming in or a disruption in it from the mobile messenger or the web messenger or the teammate app itself, or another one is we do a lot of tracking around how the teammate moves around our application in general. And if we see a deviation on that, again, we know something's up. And we'll figure it out. Like years ago, it would be the database table, or the database view is the first one I would look at, because if the databases are having a problem, maybe it's the databases, but if there's no queries going to the database, you know there's also a problem. It might be the database fault, but you know there's a problem. But this is like just this has gone up in the priority for me now.
Yeah. And I think quite interesting as well that you have the choice that you roll back by default once it kicks in, and then you can do the investigation, right? But I think that's probably just there that it will probably have quite a few minutes there, because otherwise, if just people looking at things and having to open a few pages and seeing what was deployed or not, then you're already using up 2 or 3 minutes there, right? So
no, exactly. Like there's over the years there've been so many incident reviews where like the question would be, so why didn't you roll back, or why didn't you roll back quicker? Or someone would try to like say a pull request went through that was the cause of the problem, and they would try to do a revert, and then they'd let it go through a testing pipeline and things like this. Like we get from when you click merge to in production, it's like about 13 minutes. So it's like it's fast, but 2 minutes is faster than 13 minutes.
Yes.
And so like with any of these things, like we try to set up like the humans and the first responders to be set up with all of the tools. But if there's things that we know works really well and we can get a bot to do it, then we get the bot to do it. And we've made sure that rollbacks at Intercom are an always safe thing to do. And if there are occasions, and sometimes there is, if you're switching like between databases or something like that, we just block that, and we don't allow rollbacks at that point. But that's super rare, and typically that would be some of the infrastructure engineers running that.
That's It's very interesting. Thank you. And maybe continuing in the kind of the incident response theme, right? And I would love to get a kind of a bit more detailed, right? And we did have recently, a few weeks ago, a big incident with AWS in their US East 1 region, and I know that it impacted you. So can you take us through how that looked like for you?
Yeah, sure. So it's a pretty good example of how like our heartbeat metrics work in reality. So I think it was like 7:48 and 30 seconds was the first time AWS had issues, and our internal incident that paged strike, so like our voluntary on-call out of hours service, they were paged at 7:49 UTC, and it also paged in an incident commander immediately. So we were able to, like the first responder, they were able to see that there was basically a cliff drop in our core metrics, and several minutes after that, she paged in the critical response. So basically, she marked the incident as critical, and it's our highest level. Typically, we have 0 to 1 of these per year. But she pretty quickly understood that this is different from other ones. And that at 7:54, while I was making espresso for my wife and I got paid. I looked at the critical one. I was like, really? It's like quite rare.
Yeah,
and then I went upstairs, and then I saw that we were going to have a day of it.
Yeah. And how... And can you tell us a bit more into kind of, I don't know how much you can share, but kind of how from an infrastructure perspective, how did you handle it?
Yeah, no, so like, when I went upstairs, I verified that the heartbeat metrics were broken. So like that's a Datadog bash dashboard. We also, just to make sure that it's not a metrics issue, when we create that channel, we link into Honeycomb, which we use for high cardinality observability. So I click on that link. I also see it's broken. So then you're like, okay, something's really broken. I go to the exceptions dashboard, and then I see it's Seahorse. And then one of my colleagues who was just joining the call as well was like, yeah, that's the AWS client. I was surprised because like I didn't recognize the Seahorse, and I've been in hundreds of incidents. So then like with a quick look at X, I realized this isn't us. This is something much larger than us. And then you started just paging in various people that you knew would be able to help, like over the next while as you try to mitigate. It did impact Intercom. So DynamoDB is one of our core data stores. So we use it, like the primary use case for it is storing the key value data related to our customers' end users. So for example, let's say you were a retail business and you had customers, maybe you would track what's in Intercom, what's in their basket, what tier they're signed up for, how much is their typical monthly spend, a bunch of things like that. We have a big JSON blob of all of that data, and we use DynamoDB for that. So it's absolutely core to how Intercom works, and it was effectively down. And our ability to log into into AWS was down. Ability to create cases. There was a lot of things that was just down. So until DynamoDB returned, which was about 2.5 hours, we were in US East region, we were fully down. So that was the stage where there wasn't really very much like we could do from an engineering response team. But then the next, I think it was like 10 hours or 11 hours, then we were at, like once DynamoDB was back, like the copies, there was still, AWS still had issues, but then we were able to actually do engineering work to get the app up and operational to some degree.
Thank you for sharing. And during that time was then, I guess your Europe instance was just running, or did you also a few dependencies across?
Yeah, no, the EU region was fine. So there was some impact, but it was due to third-party integrations where they were actually impacted by the same incident. So like one of the interesting things, like aside from the first 2.5 hours from then out, and why our monolithic architecture was kind of interesting, was that we have again, focusing on the US region, we have many clusters. So we have 300-400 clusters that do various different work. For example, like the web fleets or various shapes of async worker. When the incident started just before 8, that was a relatively low point in the size of our infrascaling. And then when DynamoDB went down, we scaled down all of our infrastructure to like basically our nightly min sizes. And part of like the long tail part of the AWS incident was the inability to get new EC2 instances. So we were effectively at our low point in scale, but then our traffic, like the European traffic first, and then US traffic later, they were all coming online. So we had this web fleet that would be at 20% of max peak capacity, trying to do all of the work. So some customers were likely down that also use Intercom, so maybe the traffic would be a little bit lower on a day like that. But we basically didn't have enough ping box or boxes for the messenger or boxes for the teammate app. But what was nice about our monolithic architecture is we've like all of the EC2 instances, they're all running the same thing. So we were then able to take, say, a bunch of backfill workers or just async, less priority, less important work, and we'd be able to point to them and say, okay, you're now a web box. And they would reply, I'm now a web box, and then go and start serving web traffic. So we were able to get enough instances from that point of view to service that. But then the next bottleneck that we hit was that VTGate layer that I mentioned earlier, like the proxy layer, it scales up and down. Like it's a lot of infrastructure at peak, and it goes up and down. So it was in a low place as well because we effectively weren't making any MySQL queries. And it's a very different shape of box, and we had difficulty getting any instances for that. So like our vendor PlanetScale, they were able to help and do some things that was able to mitigate some of it, but it was the bottleneck. Like we at this point, we had enough web boxes to serve all of our customer traffic, but there wasn't enough capacity in the proxy layer to serve it. So like basically database queries were slower. So the way we would see it in the metrics and the way we saw it like in the heartbeat metrics was just a depression. You could see the Intercom worked. It was just slower. When things are slower, like people do less stuff. So you just saw that. And then we also turned off various commenting type things. Like we're pretty ruthless about cutting out features that didn't service the core customer product until we were able to get capacity again.
And was then any kind of, I think you shared some of the impact as well, but were there any learnings from it? I mean, would you do something, or are you trying now to do something different overall in your architecture or infrastructure because of kind of the experience?
Yeah, like certainly with the VTGate layer. So what we changed is it can only scale up. So it went from I'm going to make up numbers here. Like let's say from 40 instances to 120. We just set them in at 120, and as it scales, or like as our peaks get more peaky and we add in more instances, then we will scale up and not scale back down.
Okay. So
that like it was in all of our infra, that was largely the only bottleneck we weren't able to work our way around. So like we're going to make sure that if there's an instance of this shape again, then like it's just not going to affect us. And another thing was, it's less related to our infra, but when we had this issue, from initial impact until our status page was updated, it was like from the absolute first error until our status page was updated, it was about 10 minutes. But like during an incident like this, that is like critical. We also want to proactively reach out to our customers in other ways. And when we were not able to log into AWS and get at other data in AWS, we were not able to send some of those proactive messages to our customers in the way we would have wanted to. So we've had to build like completely orthogonal to any of our infrastructure mechanisms to be able to reach out to our customers. So like if all of this is on AWS, then we need something in Google or somewhere else to just be completely independent of this. That was for the first 2.5 hours. Once our app was working again, we were able to put a banner within our app to be able to say, hey, there's increased latency, click here to look at the status page. And then we kept that updated then.
Like you do also provide as a service to your Intercom customers, right? That they can
of course.
They can have that. And I do see that. I do know that your kind of integration with Incident.io also allows for integrating with their status page and helping with that communication as well, right? So that's it's definitely important. As you're saying, it's only 10 minutes, but it's very important 10 minutes, right? So if you can have that communication out earlier, then I see that.
Yeah, and actually on that, like a recent thing that we've done is on our because like that 10 minutes, like our customers want faster. They see a problem, they quickly want to understand, is it the VPN in their office or some other local issue? Because there are plenty of times there is local issues. And so they want to be able to go to our status page, and like those 10 minutes or 6 minutes or 5 minutes, they can feel like an eternity if you've got 1,000 teammates trying to do work. So like on our status page now, we link off to a public-facing version of our internal heartbeat dashboard. So now, as soon as there is an incident, if you see anything going wrong at all, you can click on this link, and you'll be brought to a Datadog dash that is very similar to what we see.
Okay.
So again, this is trying to short circuit that. Like, it is us, and then also if this drops off, we communicate to our customers that we're working on this. We know about this. We're working on it. We may not have updated our status page yet, though.
Very cool. Thank you for that. It's brilliant insight there, and thank you for sharing that. I think we're getting close to wrapping up. I would just like to end with a couple of rapid fire questions for you. And the first one would be if you have any kind of book, podcast, thought leader that you follow that you would recommend to the audience.
Yeah, so there's a book. It's Accelerate, the Science of Lean Software and DevOps. So when I joined Intercom 9 years ago, Intercom did a lot of things radically different from my previous companies. And it was about 2 years later that Accelerate came out. And finally, there was a book version of what we do in Intercom that I could give people, either to candidates looking into Intercom or to people who was joining. So I could give them this book and not like have to point them to a bunch of Intercom blog posts or internal docs or something like this. So I've bought many, many, many copies of that book.
And would you have any, or do you have any professional advice that you would give to your younger self? Or, I mean, could be your younger self or someone just starting right now in this career. Any advice that you would share?
Yeah, I think it's it's become an expert in the core tools that you use. So if something is like really crucial to how you're going to do your job, like get really good at it. And so anytime I've not done this, it's come back to bite me. Like for example, when I joined Intercom, I joined as a product engineer. For the first month or two, I didn't really learn Ruby on Rails. We had a little bit of Java in Intercom at the time, and I was doing some Java stuff. And what I should have done is day one, or preferably day -14, is go straight into it. And then so, luckily, I noticed this, and then I devoured basically every book I could find, every website, every tutorial, and then read through those whilst with our code base open and learning. Okay, so I'm learning this concept about, say, active record. Okay, how do we use it in Intercom's code base? And then spent a lot of time doing that. And I think that was something that set up like my career in Intercom really well, because I quickly went from being like 10th percentile in this to be 90th percentile across not very long, and then it really stood to me.
Yeah, and I would imagine that now that I feel like that's probably a good use case for AI as well, kind of from a learning perspective and trying to learn the code base and all that. So that example that you were saying, where are we using this kind of case, right, or this way of doing things, then you can probably pretty easily get to that answer with some help from AI, right? So
yeah, no, it's incredible. It short circuits so much stuff that I would have done in the past. It's amazing.
Yeah, very cool. And so, very last question: to you, scalability is
so the discipline of building systems that reward success instead of punishing it. So like, more users, more engineers, more data, whatever. Like whenever that's growing, it should mean success, not stress and incidents and things like that. But like, having said that, like there's also a balance. We don't want to over-engineer things here.
Yeah.
We don't want to build a perfect system that will scale infinitely and then you don't have any customers. So I think anytime you see scaling issues, first have a little celebration that you're alive and that you're doing well enough to have scaling issues, and then get back to actually solving the problem.
Nice, wonderful, Ryan. I think that's a really good way to wrap up the episode. Thanks a lot for coming by.
Yeah, no, thank you.
And that's it for this episode of the Smooth Scaling Podcast. Thank you so much for listening. If you enjoyed, consider subscribing and perhaps share it with a friend or colleague. If you want to share any thoughts or comments with us, send them to smoothscaling@qit.com. This podcast is researched by Joseph Thwaites, produced by Perseo Mandilo, and brought to you by Qit, your virtual waiting room partner. I'm your host, José Quaresma. Until next time, keep it smooth, keep it scalable.